I'm still just picking some random physics problems and I'm solving them. So if you like this, that's fine. If you don't like that, just skip over this one. I'll get back to more Lagrangian mechanics stuff in the next semester. Okay, so here's a problem I picked. It looked kind of cool. I like to pick the harder problems. It looked like it was harder. I haven't worked through this one yet, but it has a rocket that's launched from a well with an initial velocity of 80 meters per second, and then the engines fire. I drew a little picture right there. Until with an acceleration of 4 meters per second squared until it gets to an altitude of 1,000 meters. 3 questions. How long is it in the air? So it's going to go up, it's going to accelerate, it's going to keep going up, and then it's going to come back down. So how long is that whole thing? Number 2, what's the maximum altitude? Because when this shuts off, it's still moving. And then finally, what's its velocity when it hits the ground? Okay, there's a bunch of ways to solve this, and I'm going to make a graph of this in Python too, just for fun. But this is the kinematic section. So we could derive the kinematic equations, but let's just write down the most important kinematic equations. So the kinematic equations in one dimension, and this is just all in one dimension, I'll write them as the following. First we have, and I'm going to use y. We have this one, y as a function of t, is the initial y, I'll call it y1, plus the initial y velocity, v1t, that's a t, plus 1/2 a t squared. And then I have the equation for the velocity, v as a function of t, is the initial velocity, v1, plus a t. This really should be delta t. Yeah, let's rewrite these. I'm going to write it like this. y2 is y1 plus v1 delta t plus 1/2 a delta t squared. v2 is v1 plus a delta t. And then finally, you can manipulate these equations and get one without a time. And it looks like this. v2 squared equals v1 squared plus 2a delta y. So in this case, I wrote these like delta t's because we actually have 2 different motions. We have two sections. We have this section right here where it has a constant acceleration going upwards of 4 meters per second, and then we have the second motion going from here back down. Okay, and actually we have 3. You could say from here to there, and then the whole thing. So let's just start with this first section right here. I want to find out, I know how high it is. I want to find out how fast it's going and how long that took. So let's just call this section 1. I'm going to call this v1, the velocity it starts with. I'm going to call this v2, the velocity it ends with. I want to find the velocity and the time. Well, if I want to find the velocity, I could use this equation. I could use this equation too. No, because I don't know the time. Let's use this equation right here. Okay, so I've already messed up my paper a little bit. So I'm going to use this equation. I know my initial velocity is 80 meters per second. My final velocity I want to find, I know 2 is the number 2. I know the acceleration, I know delta y is 1,000 meters. So I'm going to write this as v2 squared equals v1 squared plus 2a delta y. Okay, so that's really it. I'm going to put in my numbers in a little bit. Let's go ahead and put the numbers in. Everyone likes numbers. Okay. So this is v2 is the square root of 80 squared plus 2 times 4 times 1,000. Get my calculator out. Clear. So it's going to be the square root. I'm not good with calculators. 80 squared plus 2 times 4 times 1,000. I could have done that in my head. 1,000. I think that's it. And this gives 120 meters per second. You know what? That's not right. I guess it's right. Seems kind of slow, but that's fine. I guess 1,000 meters isn't that high compared to the speed. Well, let's find the time, and then that'll make more sense. Okay, so now I know the velocity. I can say v2 is v1 plus a delta t, and I can solve for delta t. I know a. So delta t is going to be v2 minus v1 over a. So it's going to be equal to 120 minus 80 over 4. So this is going to be equal to 40 divided by 4, so 10 seconds. It still seems a little bit off, but I'm going to go with it. Okay, so now I have, if I go back over here to my rocket equation, let's just put a box there, a box there, a box there, a box there. So this is 1, 2, 3, 4. So I have the velocity at 1, I have the velocity at 2. And I have delta t1. That's 10 seconds. So now let's do this part right here, going from here to there, and I can find out how high it goes. So I know the velocity at 2, and I know the velocity at 3. v3 is equal to 0 meters per second. Because if it's the highest it's going to go, it's moving upwards and slowing down, and then it's going to stop and start moving back down. So that would have to be 0 right there. And I want to find the height. Well, I also know the height right here. So let's just write my height equation. y3 is y2 plus v2, right, the velocity at 2, times delta t going from here to there, which I actually don't know that. Okay, well, I could solve for that. Oh, so let's not use that equation. Let's use this one. v3 squared is v2 squared plus 2 negative g delta y. So delta y is going to be equal to the difference going from here to there. So I know v3 is 0. I know v2. I just solved for that. So I get negative v2 squared equals negative 2g times y3 minus y2. And I know y2 is 1,000. So let's, that cancels. I'm going to divide both sides by 2g. I get y3 minus y2 equals v2 squared over 2g. And then I'm going to add y2 to both sides. So y3 is y2 plus v2 squared over 2g. So now I need to put in my numbers there. I'm going to do it without writing it down. y2 is 1,000. Did I put 100 in that last one, maybe? I'm gonna double check that in a second. Because I can't really see the calculator very well. I don't know if you can see that. Okay, 1,000 plus v2 squared, which is 120 squared, divided by parentheses 2 times 9.8, close parentheses equals. And I get 1735 meters. I'm going to double check this real quick. Clear. Square root 80 squared plus 2 times 4 times 1, 1, 2, 3, close parenthesis. Just looking at that. I think that's right. No. Oh, I said plus. Okay, let's try one more time. Square root 80 squared plus 2 times 4 times 1, 1, 2, 3, close parenthesis equals. Okay, 120. Okay, I'm going to go with it. Okay, so I've gotten how high it goes. Next, let's find out how long it is in the air. I know this is 10 seconds. So how long does it take to go from there back down to there? Let's just do another y equation. Okay, so the acceleration during this time is negative g. So I can say y4 equals y2 plus v2 delta t minus 1/2 g delta t squared. So the important thing here is delta t. I can't use t because I'm not using the y at t equals 0. So I do need to use this whole delta t, which is what I want to solve for. And I can do this for any time interval from t2 to t4, right? So I'm using y2 and y4, and v2 is the initial velocity. So I want to solve this for delta t. Now, you can see here that I'm going to have to use the quadratic formula, and that's fine. Okay, so let's just subtract this. I get y4 minus y2 is, oh, I want to do it this other way. 0 equals y2 minus y4, parentheses, plus v2 delta t minus 1/2 g delta t squared. Now, I have this in the form of a, b, c, right, in the quadratic equation. I'm going to go ahead and put numbers in for all these things. So I can say delta t is negative b plus or minus the square root of b squared minus 4ac, all that over 2a. Now, I'm going to get two answers here, okay? And let's just write it out. So I'm going to put b is this number right here, which is 120. It's going to be negative 120, and I'm sorry about the thunder, plus or minus the square root of 120 squared minus 4 times a, which is going to be negative 1/2 g, right? Because a is negative 1/2 g, so that's going to be plus, and then this is times 4.9. That's 9.8 divided by 2. And then c is this distance right here, which is going to be y2 is 1,000, y4 is 0. So it's going to be equal to 1,000. And then I'm going to divide by 2 times a, which is just going to be negative 9.8. Okay, so you see right here that I'm probably going to want the minus sign right here, because that's minus, 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 and this will give me a positive time. Okay, so let's just put all this stuff in. Let's see if I can get it correct. I'm going to use the positives, or the minus, and cancel. So, I need to clear. Parentheses 120 plus square root 120 squared plus 4 times 4.9 times 1,000, close parentheses, divided by 9.8 equals. And I get 31.06. So that's the time it takes to go up and back down. So t flight the whole time is going to be equal to 10 plus 31.06 equals 41.06 seconds. Okay, so we've gotten, I'm not going to make the video because I know I'm going to do it. No, I'm not going to make the graph because the thunder's really getting loud. So what's a collision velocity? So now we're saying what is V4 equals. So one more piece of paper. I can do this a couple of ways. I can say V4 equals V2 plus A delta t. Right? So I already know delta t. Delta t going from 2 to 4 is 31.06. I know the acceleration is negative 9.8. I know V2. So V4 is going to be equal to 120 minus 9.8 times delta t. So I'm going to say V4. Oh, that's it. So I'm just going to put that in. 120 minus 9.8 times 31.06 equals. And I get negative 184.4, that's double point, meters per second. And that's negative, that's good, and faster than both it started and faster than up here. Because if it starts up here and it goes up and then back down, it's going to speed up more than that. So that seems to be pretty good. Okay, I was going to make a graph, but I want to stop before it gets too loud, so that's that.